Drowning in data but starving for insights? Imagine having a superpower that reveals which problems are actually connected, so you can solve one issue and watch others disappear. That's the magic of correlation charts. In the next few minutes, I'll show you how to use them to work smarter, not harder. In this video, we'll cover what correlation charts really tell you and what they don't. Step-by-step process to create your own correlation analysis. How to use these insights to optimize any business. A correlation chart reveals how strongly two variables are connected. Think of it as measuring the relationship between two things. For example, does more study time lead to better grades? Positive correlation. Does more screen time lead to less sleep? Negative correlation. Or are two things completely unrelated, like the number of times you blink and how good your pizza tastes? No correlation. Correlation is measured on a scale from -1 to +1, +1, perfect positive correlation. As one variable increases, the other increases in perfect proportion. -1, perfect negative correlation. As one variable increases, the other decreases in perfect proportion. 0, no correlation whatsoever. The closer to +1 or -1, the stronger the relationship. The closer to 0, the weaker it is. But how do you use a correlation chart to optimize your business? Well, here are the basic steps. Don't worry, I'll go through them all using our Zero-Defect Pizzeria example. Step 1, define your question. The pizzeria manager wants to know, does increasing oven temperature reduce baking time while maintaining quality? Step 2, collect your data. The staff systematically tests different oven temperatures and records the exact time needed to achieve a perfect pizza crust. Step 3, choose the right correlation method. For continuous data like temperature and time, we use the Pearson correlation coefficient. For ranked or ordinal data, the Spearman coefficient works better. FYI, continuous data represents values within a continuous range, allowing for any value between 2 points, while ordinal data represents ordered categories where the difference between categories is not necessarily equal. Step 4, calculate the coefficient. No complex math needed. Input your data into Excel, Google Sheets, or any statistical software to calculate the correlation coefficient automatically. Step 5, visualize the relationship. This is where scatter plots come in, the most powerful way to visualize correlation. What is a scatter plot? A scatter plot is a graph where each dot represents a pair of values. For our pizzeria, each dot represents one pizza that was baked. The horizontal position, x-axis, shows the oven temperature. The vertical position, y-axis, shows how long it took to bake. When you add a trend line, or line of best fit, through these points, you instantly see the relationship pattern. The steeper the slope, the stronger the correlation. Let's look at our pizzeria's scatter plot. Each blue dot represents a pizza baked at a specific temperature, x-axis, and how long it took to reach perfect quality, y-axis. Notice 3 key elements. The pattern. As you move right, higher temperature, the dots tend to move down, less baking time. The trend line, the red dotted line, slopes downward, confirming the negative relationship. The coefficient, -0.87, very close to -1, indicating a strong negative correlation. This visualization makes it clear. Higher temperatures do significantly reduce baking times while maintaining quality. With this evidence, the pizzeria can confidently increase oven temperatures to reduce production time, serve customers faster, maintain the same quality, potentially increase daily output. The manager also wonders, does pizza size affect customer satisfaction? After surveying customers who ordered different sizes and rating satisfaction on a scale of 1 to 10, looking at this scatter plot, the pattern, the dots are scattered randomly with no clear direction. The trend line, almost horizontal, showing no relationship. The coefficient, just 0.12, very close to 0, indicating essentially no correlation. Notice how different this looks from our first example? When there's no correlation, the dots appear randomly distributed with no clear pattern. The trend line is flat and points are scattered above and below it with no consistency. This insight saves the pizzeria from unnecessarily investing in larger pizza sizes that wouldn't actually improve customer happiness. A data-driven decision that saves both time and money. Before you run off to correlate everything, correlation does not equals to causation. And just because two things are related doesn't mean one causes the other. Pizza delivery orders and Netflix streaming both spike on rainy days, but ordering pizza doesn't cause people to watch movies. Staying indoors due to weather influences both behaviors. External factors. Hidden variables might be influencing both your measures. Pizza delivery times and customer complaints might correlate not because of slow service, but because of a third factor: bad weather affecting both. Outliers. Extreme values can distort your results. One pizza baked by a new trainee at an unusually high temperature could skew your entire correlation if your sample size is small. Sample size. Too few data points can lead to misleading conclusions. Testing just 5 pizzas at different temperatures isn't enough to establish a reliable pattern. You need sufficient data to overcome random variation. Reading scatter plots correctly means looking for points that seem to fall outside the general pattern. These outliers might represent special cases or measurement errors that could skew your results. Correlation analysis and scatter plots can revolutionize how you identify which factors actually impact product quality. Focus improvement efforts where they'll have the greatest effect. Make data-driven decisions instead of relying on hunches. Optimize processes without wasting resources. Visually communicate complex relationships to stakeholders who might not understand statistics. How would you use correlation charts and scatter plots in your business or personal life? Let us know in the comments below. If you found this helpful, hit that like button and subscribe for more data-driven strategies to optimize your business.